In-context pre-training, language modeling beyond document boundaries. Large language models, LLMs, are currently trained to predict tokens given document prefixes, enabling them to directly perform long-form generation and prompting-style tasks, which can be reduced to document completion. Existing pre-training pipelines train LMs by concatenating random sets of short documents to create input contexts, but the prior documents provide no signal for predicting the next document. We instead present in-context pre-training, a new approach where language models are pre-trained on a sequence of related documents, thereby explicitly encouraging them to read and reason across document boundaries. We can do in-context pre-training by simply changing the document ordering so that each context contains related documents and directly applying existing pre-training pipelines. However, this document sorting problem is challenging. There are billions of documents, and we would like the sort to maximize contextual similarity for every document without repeating any data. To do this, we introduce approximate algorithms for finding related documents with efficient nearest neighbor search and constructing coherent input contexts with a graph traversal algorithm. Our experiments show in-context. Pre-training offers a simple and scalable approach to significantly enhance LM's performance. We see notable improvements in tasks that require more complex contextual reasoning, including in-context learning, plus 8%, reading comprehension, plus 15%, faithfulness to previous contexts, plus 16%, long context reasoning, plus 5%, and retrieval augmentation, plus 9%. Can GPT models be financial analysts? An evaluation of ChatGPT and GPT-4 on mock CFA exams. Large language models, LLMs, have demonstrated remarkable performance on a wide range of natural language processing (NLP) tasks, often matching or even beating state-of-the-art task-specific models. This study aims at assessing the financial reasoning capabilities of LLMs. We leverage mock exam questions of the Chartered Financial Analyst (CFA) program to conduct a comprehensive evaluation of ChatGPT and GPT-4 in financial analysis, considering zero-shot (ZS), chain of thought (COT), and few-shot (FS) scenarios. We present an in-depth analysis of the model's performance and limitations, and estimate whether they would have a chance at passing the CFA exams. Finally, we outline insights into potential strategies and improvements to enhance the applicability of LLMs in finance. In this perspective, we hope this work paves the way for future studies to continue enhancing LLMs for financial reasoning through rigorous evaluation. Reward-Augmented Decoding, efficient controlled text generation with a unidirectional reward model. While large language models have proven effective in a huge range of downstream applications, they often generate text that is problematic or lacks a desired attribute. In this paper, we introduce Reward-Augmented Decoding, RAID, a text generation procedure that uses a small unidirectional reward model to encourage a language model to generate text that has certain properties. Specifically, RAD uses the reward model to score generations as they are produced and rescales sampling probabilities to favor high-reward tokens. By using a unidirectional reward model, RAD can cache activations from prior generation steps to decrease computational overhead. Through experiments on generating non-toxic and sentiment-controlled text, we demonstrate that RAD performs best among methods that change only the generation procedure and matches the performance of state-of-the-art methods that involve retraining the language model. We further validate that RAD is effective on very large language models while incurring a minimal computational overhead. Llemma, an open language model for mathematics. We present Llemma, a large language model for mathematics. We continue pre-training code Llama on the Proof Pile 2, a mixture of scientific papers, web data containing mathematics and mathematical code, yielding Llemma. On the math benchmark, Llemma outperforms all known open-base models, as well as the unreleased Minerva model suite, on an equiparameter basis. Moreover, Llemma is capable of tool use and formal theorem proving without any further fine-tuning. We openly release all artifacts, including 7 billion and 34 billion parameter models, the proof pile 2, and code to replicate our experiments. Mini-GPT v2, large language model as a unified interface for vision-language multitask learning. Large language models have shown their remarkable capabilities as a general interface for various language-related applications. Motivated by this, we target to build a unified interface for completing many vision-language tasks, including image description, visual question answering, and visual grounding, among others. The challenge is to use a single model for performing diverse vision-language tasks, effectively with simple multimodal instructions. Towards this objective, we introduce Mini-GPT v2, a model that can be treated as a unified interface for better handling various vision-language tasks. We propose using unique identifiers for different tasks when training the model. These identifiers enable our model to better distinguish each task instruction effortlessly and also improve the model learning efficiency for each task. After the 3-stage training, the experimental results show that Mini-GPT v2 achieves strong performance on many visual question answering and visual grounding benchmarks compared to other vision language generalist models. Our model and codes are available at the project's website. Farzi data, autoregressive data distillation. We study data distillation for autoregressive machine learning tasks, where the input and output have a strict left-to-right causal structure. More specifically, we propose Farzi, which summarizes an event sequence dataset into a small number of synthetic sequences, Farzi data, which are optimized to maintain, if not improve, model performance compared to training on the full dataset. Under the hood, Farzi conducts memory-efficient data distillation by eye, deriving efficient reverse-mode differentiation of the Adam optimizer by leveraging Hessian vector products, and 2, factorizing the high-dimensional discrete event space into a latent space which provably promotes implicit regularization. Empirically, for sequential recommendation and language modeling tasks, we are able to achieve 98 to 120% of downstream full data performance when training state-of-the-art models on Farzi data of size as little as 0.1% of the original dataset. Notably, being able to train better models with significantly less data sheds light on the design of future large autoregressive models and opens up new opportunities to further scale up model and data sizes. Interactive task planning with language models. An interactive robot framework accomplishes long-horizon task planning and can easily generalize to new goals or distinct tasks, even during execution. However, most traditional methods require predefined module design, which makes it hard to generalize to different goals. Recent large language model-based approaches can allow for more open-ended planning, but often require heavy prompt engineering or domain-specific pre-trained models. To tackle this, we propose a simple framework that achieves interactive task planning with language models. Our system incorporates both high-level planning and low-level function execution via language. We verify the robustness of our system in generating novel high-level instructions for unseen objectives and its ease of adaptation to different tasks by merely substituting the task guidelines without the need for additional complex prompt engineering. Furthermore, when the user sends a new request, our system is able to replan accordingly with precision based on the new request, task guidelines, and previously executed steps. Please check more details on our project's website and project's website. Video language planning. We are interested in enabling visual planning for complex long-horizon tasks in the space of generated videos and language. Leveraging recent advances in large generative models pre-trained on internet-scale data. To this end, we present Video Language Planning, VLP, an algorithm that consists of a tree search procedure where we train vision language models to serve as both policies and value functions, and text-to-video models as dynamics models. VLP takes as input a long-horizon task instruction and current image observation, and outputs a long video plan that provides detailed multimodal video and language specifications that describe how to complete the final task. VLP scales with increasing computation budget, where more computation time results in improved video plans and is able to synthesize long-horizon video plans across different robotics domains, from multi-object rearrangement to multi-camera bi-arm dexterous manipulation. Generated video plans can be translated into real robot actions via goal-conditioned policies, conditioned on each intermediate frame of the generated video. Experiments show that VLP substantially improves long-horizon task success rates compared to prior methods on both simulated and real robots across 3 hardware platforms. Improving large language model. Fine-tuning for solving math problems. Despite their success in many natural language tasks, solving math problems remains a significant challenge for large language models, LLMs. A large gap exists between LLMs' Parset-1 and Parset-N performance in solving math problems, suggesting LLMs might be close to finding correct solutions, motivating our exploration of fine-tuning methods to unlock LLMs' performance. Using the challenging math dataset, we investigate 3 fine-tuning strategies. 1. Solution fine-tuning, where we fine-tune to generate a detailed solution for a given math problem. 2. Solution cluster re-ranking, where the LLM is fine-tuned as a solution verifier evaluator to choose among generated candidate solution clusters. 3. Multitask sequential fine-tuning, which integrates both solution generation and evaluation tasks together efficiently to enhance the LLM performance. With these methods, we present a thorough empirical study on a series of Palm 2 models and find 1. The quality and style of the step-by-step solutions used for fine-tuning can make a significant impact on the model performance. 2. While solution re-ranking and majority voting are both effective for improving the model performance when used separately, they can also be used together for an even greater performance boost. 3. Multitask fine-tuning that sequentially separates the solution generation and evaluation tasks can offer improved performance compared with the solution fine-tuning baseline. Guided by these insights, we design a fine-tuning recipe that yields approximately 58.8% accuracy on the math dataset with fine-tuned Palm 2L models, an 11.2% accuracy improvement over the few-shot performance of pre-trained Palm 2L model with majority voting. Ranking LLM-generated loop invariants for program verification. Synthesizing inductive loop invariants is fundamental to automating program verification. In this work, we observe that large language models such as GPT 3.5 or GPT-4 are capable of synthesizing loop invariants for a class of programs in a zero-shot setting, yet require several samples to generate the correct invariants. This can lead to a large number of calls to a program verifier to establish an invariant. To address this issue, we propose a re-ranking approach for the generated results of LLMs. We have designed a ranker that can distinguish between correct inductive invariants and incorrect attempts based on the problem definition. The ranker is optimized as a contrastive ranker. Experimental results demonstrate that this re-ranking mechanism significantly improves the ranking of correct invariants among the generated candidates, leading to a notable reduction in the number of calls to a verifier. Microscaling data formats for deep learning. Narrow bit-width data formats are key to reducing the computational and storage costs of modern deep learning applications. This paper evaluates microscaling, MX data formats that combine a per-block scaling factor with narrow floating point and integer types for individual elements. MX formats balance the competing needs of hardware efficiency, model accuracy, and user friction. Empirical results on over 24 benchmarks demonstrate practicality of MX data formats as a drop-in replacement for baseline 32-bit floating point for artificial intelligence inference and training with low user friction. We also show the first instance of training generative language models at sub-8-bit weights, activations, and gradients with minimal accuracy loss and no modifications to the training recipe. When can transformers reason with abstract symbols? We investigate the capabilities of transformer large language models, LLMs, on relational reasoning tasks involving abstract symbols. Such tasks have long been studied in the neuroscience literature as fundamental building blocks for more complex abilities in programming, mathematics, and verbal reasoning. For regression tasks, we prove that transformers generalize when trained, but require astonishingly large quantities of training data. For next token prediction tasks with symbolic labels, we show an inverse scaling law. Transformers fail to generalize as their embedding dimension increases. For both settings, and we propose subtle transformer modifications, which can reduce the amount of data needed by adding 2 trainable parameters per head.